Hello, fellow chemists. In this video, we're going to take a look at the concepts of atomic number, mass number, and isotopes. This is listed as an intermediate level video because it does assume that you have some basic understanding of atomic structure. If you need to review that topic, I'll put a link in the upper right-hand corner. So let's get started. Atomic number, mass number, and isotopes. These are all talking about parts of the atom, basically protons and neutrons, and how they exist within an atom. So if we take a look at the first term, atomic number. The atomic number is, simply put, the number of protons in an atom. So the number of protons in an atom. And there's a couple interesting things about the atomic number. First thing, the number of protons in an atom cannot change. And I'm going to put a little asterisk next to that because there are some qualifiers that we have to put in for that. And the atomic number is on the periodic table. I'll put PT for periodic table. So if we pull up and zoom in on our trusty periodic table here, all of these whole numbers at the top of elements, like for hydrogen, that number 1, that is the atomic number of hydrogen. And that also means that hydrogen has 1 proton in it. If we take a look at my favorite element over here, carbon, the atomic number for carbon is 6, and that means carbon has 6 protons in it. Now, what do I mean by it cannot change? The atomic number cannot change. Well, really what that means is the number of protons in an atom cannot change. You can add neutrons into an atom. You can take neutrons out of an atom. You can add electrons into an atom. You can take electrons out of an atom. But however many protons are in an atom, it stays that way. Now, there are some rare cases, and these are like nuclear reactions like fusion and fission, where so much energy is associated with the atom that it actually will gain or lose a proton. But we're not going to be doing nuclear fusion or fission here. So for all practical purposes, the number of protons in an atom, or the atomic number for an atom, cannot change. And every carbon in the universe has 6 protons. If you were to somehow add a proton into a carbon, it would no longer be defined as a carbon. It would then be called a nitrogen. If you were to somehow magically add a proton into a hydrogen, it would no longer be a hydrogen. It would then be a helium. So what defines the identity of an element is actually how many protons are in that element, or what that element's atomic number is. Every single carbon atom in the universe has 6 protons, just like every single nitrogen atom in the universe has 1 proton. All right, so if atomic number is just talking about how many protons are in an atom, well, then what is the mass number? So let's talk a little bit about mass number now. So mass number is simply the number of protons plus the number of neutrons that are in an atom. So if you add the number of protons plus the number of neutrons in an atom, that is the mass number. Now, the mass number has a couple of interesting things. The mass number can change. And the mass number is not shown on the periodic table. So if we again pull up this periodic table, the whole numbers at the top here are the atomic number. The decimal numbers down here are not the mass number. Don't think that they are. Mass numbers typically are not shown on the periodic table. So mass numbers are the number of protons plus the number of neutrons in an atom. And if the mass number for an atom can change, well, then that must mean the number of neutrons in the atom can change, because we already said the number of protons in an atom cannot change. So let's kind of take a look at this. We're going to take a look at two hypothetical atoms. And I'm going to draw the little yellow circle here to stand for the nucleus. And in this nucleus, we're going to have 6 protons, and we're going to have 6 neutrons. And then in the electron cloud, and right now we're not super worried about the number of electrons. We'll talk about that soon, but not in this video. In the electron cloud, we're also going to have 6 electrons. Well, by definition, any atom that has 6 protons is a carbon. So this is a carbon atom. And this particular carbon atom has 6 neutrons in it. It's also a neutral atom, so it has 6 electrons in it. Well, now we're going to take a look at another carbon atom. And we'll draw this carbon atom over here. This second carbon atom also must have 6 protons, because by definition, every single carbon atom in the universe has 6 protons. But this carbon atom is going to have 7 neutrons in it. And then just to keep things relatively simple, we'll just say that it still also has 6 electrons in it as well. We want that to be green. So this second carbon atom will still have 6 protons and 6 electrons, but it's going to have 7 neutrons in it. But it's still called a carbon. So this is also a carbon atom. These two carbon atoms together are called isotopes of each other. They are an example of two isotopes of carbon. So we should define what is an isotope now. So an isotope is an atom or 2 or more atoms that contain the same number of protons and electrons, same number of protons and electrons, but they have different numbers of neutrons. And we can see in our example here of these two carbon atoms, both carbon atoms have 6 protons and 6 electrons. 6 protons and 6 electrons. But one carbon atom has 6 neutrons in it, and the other carbon atom has 7 neutrons in it. These are said to be two isotopes of carbon. And a common way to show an isotope of carbon is you would write its symbol. Then in the bottom left-hand corner, you would put its atomic number. That's the number of protons. And then in the upper left-hand corner, you would write its mass number, which is the number of protons plus the number of neutrons. So by writing the mass number being equal to 12, that's basically telling us we have 6 neutrons in this particular atom of carbon. So the 6 down there is the atomic number, and the 12 up here is the mass number. And remember, the mass number is the number of protons plus neutrons. Well, if we were to draw that same symbol for this carbon over here, you'd still have a 6 down there because it has 6 protons, but this would be a 13. So we would call that carbon 13, and carbon 13 is going to have a total of 7 neutrons. If you take the mass number, this 13, and you subtract out how many protons it has, 6, you get how many neutrons that particular isotope of the atom has, which in this case is 7. So isotopes are basically two atoms of the same element, in this example, 2 carbon atoms, but their only difference is they have different numbers of neutrons in them. So now what we need to talk about is, the relative amounts of different isotopes. Most carbon exists as carbon-12. In fact, over 99% of carbon exists as carbon-12, and only about 1% of carbon exists as carbon-13. So different atoms in the periodic table have different numbers of isotopes. What I mean by that is, if we take a look at carbon again as an example, it has 2 stable isotopes, carbon-12 and carbon-13. Most of carbon exists as carbon-12, 99% of it, but 1% of carbon exists as carbon-13. If we take a look at just an example of another element in the periodic table, if we take a look at, say, lithium, which is the 3rd element in the periodic table, lithium has 2 stable isotopes as well. It has a lithium-6 and a lithium-7. Lithium-6 has 3 protons and 3 neutrons, and lithium-7 has 3 protons and 4 neutrons. Approximately 92% of lithium is lithium-7, and about 8% is lithium-6. And you could go through all of the elements in the periodic table, and you would see that some of them have 2 stable isotopes, some of them have 3, some of them have 4. But that is also, the number of stable isotopes is information that's typically not shown on a regular periodic table. So atomic number is on the periodic table. Yes, it's the whole number at the top. Mass number is not shown on the periodic table. And also the isotopes, the number of stable isotopes an atom has, is also not shown on the periodic table. Okay, that is it for this lesson. I hope you learned something. If you did, make sure you subscribe and like, and I will see you in the next video.